Hey everybody, Adam with FANUC here. We've got a really good topic today. I am so glad that you guys are dropping comments with requests in these videos because I might not have even thought to do this one. And this is a very, very useful tool for advanced users. So we're gonna dive into a few things. We're gonna talk about distance before command, time after command, and how they can be coupled with point logic. As you can see on the screen, I've also felt bad that out of all my videos, I've never programmed a Delta robot for you guys. You can call them deltas, spiders, genkatsu if you're feeling sprightly. But yes, these are our high-speed pick-and-place robots. They articulate really, really cool with the parallel linkage design. You can see how this thing kind of synchronizes and moves. It's the only robot that we have that all the motors work in parallel rather than in series. So pretty cool robot. Great for high-speed applications, which is also coincidentally where you would typically use distance before and time after is in really high speed application stuff. Let me explain. Let's get started. So just to give you a little background, I went ahead and just slapped together a main program that is a really simple pick and place. Got my 4 favorite lines of code up top. Got a user alarm in there that we don't need right now. Clear that up. All right, so we just start at home. You'll see I have a nice little for loop that'll run 3 times. I'm going to move above a pick to my pick, dwell, then back up. So up, down, up. And then I'm going to go to my place, up, down, dwell, up. Repeat that, go home. Super simple program. Let's just take a look at it real quick so you can see it run and we can all start together at square one. So here we go. Robot, start at home. There's a pick, place, pick, place. We'll do that 3 times. All right, this is our baseline program. So you've started your program, you've taught your positions, you've tested it. Everything is wonderful. And let's say that what you're doing is this is a vacuum cup and you're picking up little parts, little plates, little tools, something, and your boss says, hey, we need to speed this thing up. Okay, well, speeding up, there's only so much you can do by increasing robot speeds, program speeds, changing your continuous values. There's only so much you can do. When you really have to start hunting for more time, there are some tips and tricks. And one of them that I've used is actuating the vacuum before you get to your part. So that vacuum will actually turn on your way down to the part so that the line is already energized, vacuum's being pulled, and when the robot touches the part, you can immediately bounce back up and leave. It'll eliminate the need for this line, for the wait, this little dwell, rather than get to the bottom and turn on a vacuum and then wait, we can have the vacuum already running. Now, full disclosure, yes, I could just turn on the vacuum after line 9, but I'm trying to teach you guys distance before, and this is a very primitive and super easy example. There are a million things you can do with this tool. This is one example. Let's build it. On my way to the pick, so I'm already above it, I'm on my way. I'm going to go here and say choice. And you will see that in choice, I have my time after and distance before. We're going to start by talking about distance before. When I add this, I press enter. Look what happens. It bumps this line down, gives me a dB, distance before, gives me a measurement in millimeters, and then a ... something to do. Well, I know that I'm starting 50 millimeters above my pick. That's an offset that I built. I programmed that. So I know that I'm going from being 50 millimeters above it to being down to it. So let's just say halfway, let's say 25 millimeters. So meaning 25 millimeters before I get to pick, we're going to do something. Now look at the options I have. And again, this just gets so deep, you guys. You can use your imagination and do millions of things. I'm just showing you one stupid, silly thing. But distance before, right before I get there, I can call a program. I can turn on a digital output. I can turn on or off a robot output, group output, analog output. Or we can even get into this, which is wildly fun, point logic. I will show that to you in this video. Let's start easy. Let's say I want to turn on my digital output number 1, which I have programmed to be a vacuum. So if you look at my I/O screen, I have digital output 1 is a vacuum. Let me turn it off. So basically what I'm saying in this program is I'm above the part, I'm headed down to the part, but right before I get there, that vacuum turns on. Okay, so let's also put in a line of code to turn the vacuum off at the place position. So here we are at the place, IO, DO, 1 turns back off, so we drop the part. Before I optimize my code, let's just see what this looks like. I'm going to zoom in a little bit here so y'all can see the robot motion, and you can see the output running at the same time. And you know what? Let's slow it down. We got to exaggerate this, otherwise this robot's way too fast. Okay, let's watch this together and see what we see. You'll see that on, place, off, on. You'll see that that is turning on while the robot is still in that vertical motion. Watch again closely. There it is, and now we've touched the part. So you'll see that, yep, the DB command is working. It's working well. It's turning on the vacuum before we ever get to our position. That's great. Now let's make that do something even better for us. Once that is true, I no longer need this line of code. I can completely get rid of it. I can comment it out. Turn this on. Edit, remark. There. Now there's no more dwell. I don't need a dwell because I will have already picked up the part as soon as I touched it. But that also means I don't need the robot to stop. I can use a continuous 0. The 0 meaning I'm guaranteed to get to the position, but the continuous meaning I'm going to do everything to not stop the robot. Now, obviously, we're changing directions. So there's a deceleration and an acceleration. It's very instantaneous. But you guys have seen with a fine move, that robot actually stops. Whereas with this, it's more of a bounce, kind of like bounces off the part. So if we look at that again, and again, this is super slow motion because we're running at 5% throttle. But you'll see that that robot, when we place it, it kind of dwells. When we pick it, just boop, down and up. When you're running that at 100% speed, you're going to be shaving milliseconds off of your project, or off of that position. So milliseconds times, 150 picks per second, you're going to save a lot of time. So that is one thing you can do with distance before. Obviously, there's tons and tons and tons you can do with it. That's great. Use your imagination. Let's talk about time after. So again, I need to build some hypothetical situation in my brain just so I can teach you guys the functionality. The hypothetical situation in my brain is I want to know that I'm carrying the part. We just went through all this work to just bounce off the part with the vacuum already on. How do I make darn sure that I'm still holding that before I get to the place position and that I didn't drop it or throw it or mispick it? All right, now we're thinking. Let's do that. So here's what I'm going to do. Right here is the line of code where I move back up in space. Interesting that sorry, I turned my comments off earlier. Okay, this is the line where I'm 50 millimeters above my pick. So we've done the bounce, we've done the DB, we are 50 millimeters above. Let's have some fun. Choice, time after. So now I'm going to say how long in seconds after I've retracted 50 millimeters, so I'm already up in the air, how long after that to do something? Well, I could leave it at 0. That's fine. It'll just execute right then, but let's just call it 1/10 of a second. We're hauling the mail. So 1/10 of a second after I retreat my 50 millimeters, let's check and make sure we're holding apart. Let's build some point logic. Bonus feature, guys. So with point logic, it allows you to build logic inside a single line of code. So when I highlight this, I can press enter and I get this little subroutine. You can see up here, it says that we're at line 12 of the main program. We're at main program, line 12. We're at the PR pick, and I've got a blank screen. Well, let's have some fun with this. I'm going to say if. We're going to do an if then. And I'm going to check the status of a digital input. Let's say if digital input 1 is a vacuum sensor. All right, a lot of vacuum suppliers, you know, they have a pressure sensor that when you pick apart, it senses that vacuum and it'll give you a signal that yes, I'm holding apart. Well, let's say that if digital input 1, if that vacuum sensor is off, you know, we've moved up. If that sensor is off, we have a problem, don't we? So let's just drop in a user alarm. Let's call user alarm number 1. And then for every if, there is also an end if. So here's a super simple point logic that I should be holding apart. Let's check and make sure I'm holding apart. When I'm done editing this and I'm happy with it, I hit the previous key. Gotta hit previous. And it's gonna show me a little summary. Look what this line looks like now. Line 12, above the pick, time after, point logic, vacuum sensor, blah, blah, blah. You'll see up here I'm still in a viewer mode. Once I'm happy with how this looks, and we all agree that, yep, that's what I want, I press enter again. There we go. Now that point logic is hidden. It's buried in there. It just cleans things up. So there it is. Well, we got to test it. To test it, let's first, I'm just going to hold on this sensor and say, yep, we have a happy sensor. Happy sensor, happy life. And let's run it and just make sure everything's okay with a happy sensor. Picking, placing. All right, so far we've got a very happy robot. The sensor is happy. Let's kill that sensor and see what happens next time it picks. Pick. Uh-oh, we dropped a part. Look at that. Main, line 12, user alarm 1. There we go. It actually recognized that the sensor failed and stopped the robot. Let's make this a little sexier. Let's do our due diligence. Let's be good programmers. Menu, next page, browser. Go to the, if you've never been here, this is the robot homepage browser. We can go to robot tools, comment tool, and this is where you can easily comment your registers, numeric, position, string, things like that. You can also set up your user alarms. Let's set up user alarm 1 as say dropped part. And severity, a severity level 6 means we're e-stopping the robot. If I lower the severity, it'll just give me an alarm but keep running. Different different topic for a different video. How about that? So let's go back to our main and let's run this bad boy again, and let's just make sure that the alarm shows up properly this time. Start at home, pick our part. Oh no, we don't have a part. It's because we dropped part, main line 12. So I think this is a good place to stop it here before we get too far in the weeds, guys. I really hope this helps. Distance before, get creative with it. Time after, get creative. Point logic, go all out. The sky's the limit. It is so flexible what you can do with this robot in parallel tasking to optimize time and mesh that all together. This is the difference between new programmers and experienced programmers. It's tips and tricks like this. Let me know how you like to use these functions in the comments. You'll probably help some other people by sharing that wisdom. Keep the questions and comments and suggestions rolling, guys. I'm busy, but I love getting these videos out to you. Thank you so much for watching and supporting the channel. As always, have fun coding.